All right, so welcome again, everybody. This morning, what we're looking at is coordinate geometry. We want to see if we could run through this topic that I prepared here, this handout. Basically, we're gonna cover everything now we need to for this topic, and then get to some exam type questions. Right? So let's get started. So to introduce coordinate geometry, we have to understand points on our graph. Another word for the graph is the Cartesian plane, right? So we have a pair of axes that forms the graph, the Cartesian plane. One of them is a horizontal axis. I get my highlighter. Right? This is the horizontal axis here going from left to right, horizontal line. That's called our x-axis. On the right-hand side, we have our positive numbers, so it's increasing in terms of positive numbers this way, and on this side is increasing in terms of negative numbers heading this way to the left. Right? We have a vertical axis. This is the vertical axis here. Right? Meaning up, down, top to bottom. This is called our y-axis. To the top section, it's increasing positively this way. To the bottom, increasing negatively. The center, where these two lines are intersecting, is called the origin. And at the origin, this is where we have the point 0, 0. Now, as I use or mention that term of point, we could put points like I have A, B, C, and D anywhere on this graph. And we could reference that point based on where it aligns or what number it aligns with on the x-axis and the y-axis. And we call this the coordinate of the point. So think about the coordinate of the point as an identifier in terms of the position on the graph, on the Cartesian plane. So we identify the position of a point by referencing a pair of coordinates. And I'm saying it's a pair of coordinates because we're going to have a x value and a y value. The x value is telling you what it aligns with on this horizontal axis. Well, sorry, this should be here. And the y value is telling you what it aligns with on this vertical axis on this side here. Right? So we have 4 points. A is the 0.35 because it is in line with 3 here on the x and 5 here on the y. Right? B is the point -1, 3. Right? C is the point -4, -2. And D is the point 2, -3. Right? Now, the order in which we would write these coordinates will always be x first, followed by y. So you write the x coordinate first, and then the y coordinate. All right? Now, there are 4 quadrants on your graph. You have the first quadrant. This is the second quadrant. This is your third quadrant. This is your fourth quadrant, right? We're using the word quadrant because it's divided into 4 areas. In the first quadrant, what you will notice is that any point that lies in this area here, right? Both values of x and y are positive. So any point that I put here, you will find that the numbers that we're referencing for that point or the coordinates of that point is positive, right? And it's important. Why is it important that I share this with you? So that even if we don't have a graph in front of us, when you see a pair of coordinates, automatically in your mind, you should know which one of these quadrants the point is lying in. So if I have a coordinate with 2 positive numbers, I know that this has to be in the first quadrant, right? Which is the top right-hand side. If I have a pair of coordinates and the x is negative, look at this here, the x is negative. That should automatically signify to me that this point is in the second quadrant, top left-hand side, right? Because to have a coordinate like this, it means that it has to be on the negative side of the x-axis. If both x and y coordinates are negative, that means that we are in the third quadrant, bottom left, right? Anything in this area here, if you look at what we have to reference on this side here, would be negative. Everybody see that? And finally, if something lies in the fourth quadrant, the x is positive and the y is negative, right? So again, the importance of this is for you to have a visual understanding or in your mind to be able to reason or work out where a particular point might lie. This is important when we draw in graphs or lines and other figures, right? Good. So I have a short video here that we're going to look at in terms of how to write the coordinates of a point, right? Not too long. We might look at the whole thing. We look at a few examples. Everybody could see it's not somebody wants to come into the room. Hi Ivano, welcome. How are you doing? So we just introduced the coordinate geometry. I was telling the class about the graph. The graph contains is made up of a horizontal axis called the x-axis. This is a line, think about it like a number line that running from left to right. The right-hand side is the positive side of the axis, and it's increasing here in terms of positive numbers. Left-hand side, negative side of the axis, and it's increasing as you go further left. The y-axis is the vertical axis. The top section is positive. We have increasing positive values. Bottom section, increasing negative values as you go further down, right? Using these pair of axes, we could draw a point on the graph, right? And we're going to look at a video now in terms of writing the coordinates of a point. So if we put a point on our graph, we could be able to reference this point by a pair of coordinates, usually x and y coordinate, and that's going to tell you its position with respect to the x-axis and y-axis. So let's see if we could, everybody could see this video. Is it big enough for everybody? Let's give them a little thumbs up. I'm gonna make sure I have the little, right, seeing thumbs up there in my chats, right? Tell me if you could hear it as well too, right?
In this video, I am going to show you a
Everybody
group
hearing?
of
Thumbs
points,
up if you're hearing.
and what I'm going to show you
Okay.
is how to get the coordinates for that point. So I'm going to go in alphabetical order. And again, I wanted to remind you that our x-axis goes from left to right. Notice how as you go to the right, the numbers get bigger. As you go to the left, the numbers get smaller. And our y-axis, which goes up and down, as you go up, the numbers get bigger. And as you go down, the numbers get smaller. So first what I'm going to do is locate my first point, the point A. My point A goes from the origin to the left and up. And how I'm going to tell my reader how to get to that place is first by starting with my x, which is left -6. And how far up we go. And if you notice, we go up 6 units. And again, our points are always in the order x comma y. My next point B is on the y-axis. So from the origin, we did not go left or right. We just went straight up. So to tell your reader that you did not move to the left or right, you say 0. Now 0, how far up did we go? We went up 9 units. Point C is in quadrant 1. And to get to this point from the origin, we went to the right and up. So you always have to go in the x direction first, which is left or right. So we went to the right. How far to the right did we go? We went 6 to the right. And how far up did we go? We went up 8. Then for point D, over here, still in quadrant 1, we went over to the right 2 units. And we went up only 1 unit. For point E, on the x-axis, from the origin, we went to the left, which is -4. And we did not go up or down from the x-axis, so that's going to be 0. Next is letter F, which is in quadrant 1, 2, 3. So we go to the left, -4 units. And this time our point went down. It went down to -3. I have next the point G over here in quadrant 4. Again, 1, 2, 3, 4. For this point from the origin, we went over 8 units and down 2. So to the right, 8, and down 2. Then we have our point H in quadrant 3. So I'm going to go left from the origin, 7 units, and down also 7 units. And then my last point that I have, point I, we went to the right 4 units, and we went down 6 units.
Right? So let me just back it up a bit here.
In this video,
My bad. Come back a bit to talk about something. Right. So a few things that I want to draw to your attention, right? You see how important understanding the quadrants could assist in determining whether you're going to have a positive or negative value for your X or Y, right? That's one. Notice that she's always making reference in terms of how much times you either move to the right or left to determine your X coordinate. So X coordinate, we're talking about a horizontal movement, either going to the left or to the right. Okay. Another important thing is that look at the points that are actually on our Y and our X axis. Look at the point B and look at the point E. Right? Notice that for those points, because there was no movement on the axis in terms of just now, somebody wants to come in the room. Meeting tab admit. Right. Right. Notice for points B, right, we have 0, 9. Right? That's because we are on 0 for our X, and we are just moving up the Y axis. So we didn't move to the left or right. So the X coordinate is 0. Everybody understand that? Give me a thumbs up if you understand that. So the X coordinate is telling us about movement either to the left or right. But if we didn't go left or right, that means that we're still on the origin, 0. So the origin is like our base point. Mark, I understand that? I didn't see it, but thumbs up. So for each point, you think about it as, all right, I am at the base. The base is the origin. This is where everything is starting from, hence the name of the origin. And we are making reference in terms of movement either to the left or to the right, horizontally, and then up or down vertically. So, for example, again, with the point A, from the origin, I move 6 spaces to the left. So that's a -6. Anytime you move to the left, that's a -6. And then I want 6 spaces up. That's a positive movement on the Y. But for the point B, there was no left or right movement. We are still at the origin. All we did is we moved 9 spaces up, right? Similarly, for the point E, we move 4 spaces to the left. So that's a -4. But I didn't go up nor down. So I have a 0 for Y. Yeah, everybody understand that? All right. Now we need to do the opposite, or at least understand the opposite. Look at a point and then be able to plot or state basically what the coordinates of the point is. So let's take a look at that. Right, everybody seeing? Give me a thumbs up if you're hearing too.
in this video, I'm going to show you how to plot a point and label it on the coordinate grid. So I'm going to continue going in my alphabet from the previous video. And what I'm going to start with is this point J at +4, +6. So again, I want to remind you that an ordered pair always goes first X and second Y. And our X axis goes left to right. And our Y axis goes up and down. So if X goes left to right and you see a +4, from the origin, we're going to go +4, And you see how your y says +6. Notice these are the positive y's and these are negative y's. I'm going to go +6, so I'm going to go up 6. And that is how I'm going to label my point J. My next point is -7 in the x direction and -3 in the y direction. So on my x-axis here, I'm going to go over to -7. And then because my y is also negative, I'm going to go down 3. And that would be my point K. L is 0, 5. So I'm not going to go left or right from the origin. So from the origin, starting at 0, 0, I'm only going to go up 5 units. 1, 2, 3, 4, 5. And that would be my point L. My next point M, my x direction, I'm going to go left to the -1 and then up 4 units. So left 1, up 1, 2, 3, 4. And here's my point M. My next point, letter N, is 2 in the x direction. So we're going to go to the right, and -1 in the y direction. So we're going to go down. So right 2 and down 1 is N. Letter O is in the x direction, -8. So we're going to go on the x direction over to -8. And in the y direction, up 5. 1, 2, 3, 4, 5. Letter P, we're going to go left 1 and down 2. Again, x goes left to right. That's your first ordered pair. And the second ordered pair goes up and down. So left 1, down 2. And that's point P. Letter Q is -6, 0. So from the origin, I'm going to go -6. And I'm not going to go up or down because that says 0. So that's my Q. And then the last point, letter R, is 10, -4. So in my x direction, I'm going to go to +10. And in the y direction, I'm going to go down 4. And that's the point R.
All right. So now we know how to plot points on a graph and how to read points that are already plot on the graph. And that's important because everything else here is based on understanding those coordinates. And some types of questions would either tell you what the coordinates of the point is, or they could give you a graph. And you have to read the graph to know, well, okay, this point is the point 1, 2, or this point is the point 5, 5. After understanding that, you will then move on to getting questions that might involve doing a number of things with these points on the graph. Now, when we connect 2 points on the graph, we would form a line or line segment, okay? And for a line segment, we could do about 3 or 4 different things. We could find the length of that line or the distance between the 2 points. We could find the midpoint of that line. We could find the gradient. The gradient has to do with the slope of the line, right? How steep or how flat that line is. We could also find the equation of the line. So for any line, let's take, for example, AB here. There's a number of infinite points. Well, a number of finite points, I should say, between A and B, right? A set of points. So any point on this line, if I circle a point here, would have some X or Y coordinates. There's an equation that we could write for this line that will always describe the relationship between X or Y so that you could find any point on the line. That's called the equation of a line. So we're going to talk about each of these one after the other. The first one we're going to talk about is the length of a line. So on the right, I have the steps on how to find the length of a line. Each one of these have a particular formula. You know how I like to do these questions. I have a series of steps that I would want you to follow every time you're doing a question like this, right? And I also have a drawing on the left to help us understand what is taking place, right? Now, not every question you get is going to have the diagram. Some questions will just be a written question, right? And you will use the coordinates that you have in order to find the length of the line using the formula that I quoted. All right, so let's talk about this. So we have 2 points here. The 2 points that I have is the point A, which is 1, 2, and the point B, which is 5, 5. And I have this green line here that is connecting the 2 points as a line segment. And I want to calculate or figure out the length of the line. Or we could say it another way, the distance between the 2 points. Both of them mean the same thing. Now, the answer that we will get will be expressed in terms of units. Now, we could do this 2 ways. If you have a graph in front of you, you could actually calculate the horizontal movement, right? The horizontal movement, we're going to look at where this first point is and how far along the x-axis we move to get to this other point. If we look at that, that's a total of 4 units. Look at the blocks. 1, 2, 3, 4 blocks. So we move 4 times to the right, and then we move 3 blocks up. 1, 2, 3 blocks. Now, if you look at that movement that I just described, what we're forming basically is our right angle triangle. Everybody seen the right angle triangle? You all seen that? Give me a thumbs up if you see that. So the line segment AB is actually forming the longest line in the triangle called the hypotenuse. Now there's a theory or theorem in geometry used to find the length of the longest line in a right angle triangle called the Pythagoras theorem. Right? Some of you may have done it already with me. Some of you might be new to you. But basically, the Pythagoras theorem says that the length of this longest line in the right angle triangle, which is called the hypotenuse, could be found by taking the square root of the sum of the squares of the other 2 sides, which is these 2 sides here. Right? So that's a long explanation about how they come up with this formula. Right? Outside of all of that, which you really might not need to know to explain this or to work it out, I think more importantly is the steps necessary to find the length of a line. And that's what we're going to go through now, right? So, anytime you're doing a coordinate geometry question, the first step that I want you to do, the first 2 steps that you're going to find common to everything we're looking at today, is going to involve identifying the 2 points that you're working with. For the length of the line, we need the 2 endpoints because we're trying to find the length of the line. So it can't be any random point on the line. It must be the beginning or the starting point and the end point. Once you identify the endpoints of the line, in this case is A and B, I want you to label them. Now remember, the coordinate of a point is made up of a x and a y coordinate. But we have 2 coordinates here. So I am labeling one x1, y1 because that's my first point. And the other one I'm labeling it x2, y2. This is important. This line here is important because the formula is quoting x1 and y1 and x2 and y2. So I want you to visually be able to see what number is x1 and what number is y1. The third and another important step is to always write your formula. Now, this is my approach to doing these questions, right? And if you follow it in this particular format repeatedly, every time you have a question like this to do, you are reinforcing the steps and you have one constant way of approaching this problem all the time. So it doesn't matter whether they change the question or what. You always approach it like this. And that way, your chances of getting it wrong would be a lot less, right? You reduce your chances of getting it wrong because you have a system in place in terms of approaching this question. So we identify the points, we label them x1, y1, x2, y2, and then we write our formula. The formula for the length of our line is the square root of x2 minus x1 squared. So we're actually working out this value here. x2 is 5. x1 is 1. When I subtract 1 from 5 here, I am going to get the horizontal movement that I was mentioning before, which is 4. Right? So it's going to tell you how much spaces it moved to the left or right. Everybody understand that? My thumbs up if you're okay with that first part. Good. Then we're going to add the difference between y2 and y1. So y2 is 5, y1 is 2. If I subtract that, I'm going to get 3, which is this vertical movement here. So you see how we could work out the 3 from the formula. Right? Now that we have these values, this is just like I mentioned with the Pythagoras theorem. We find the square of these values. Now, an important point to note here is anytime you square a number, whether the number is positive or negative, the answer you will get will be a positive answer. Because if I square -2, that means -2 by -2, I will get +4. So the answers that you're going to get in this line here, both of them should be positive numbers. You should never get a negative number on any day. If you get a negative number, it's because you did something wrong, right? You forget that to tell you, and the square of any number is going to be positive, right? So I'm going to get 16 and 9. And if I add 16 and 9 together, I will get 25, right? And the square root of 25 will give me 5 units. So the length of this line, AB, or the distance between AB, is a distance of 5 units. If we measure this, we should get 5. Everybody understand that? Give me a thumbs up if you do. Oh, I say I want to try to ask it another way. Give me a thumbs down if you don't understand. Promise myself to start doing that. Right, so no thumbs down, right? Good. So this is what I'm doing here. Everybody could see it still, right? So I have a question here for you to do, and this is what I was telling you. You do have a diagram for this. Given that the line XY has the endpoints 2, 5, 8, 13, calculate the distance between X and Y. In other words, the length of XY. So you see the steps there still. Follow the steps and work out this problem for me. Right? Follow the steps, work out this, and tell me what you get. Or tell me when you finish. So I will do the solution on it, and then we look at the midpoints. Right, so let's look at the solution to this. Right? From a pen. Right, it's in a different color. So first thing, we say 2 points, label the points. So we have X is 2, 5, right? Identify the points. Y is 8, 13. The next thing I want to do is I want to label them X1, Y1, X2, Y2. Then I want to quote my formula. Length of line. I can put XY, since that's the line now we're finding. It's the square root of X2 minus X1 all squared plus Y2 minus Y1 all squared, right? So the 2 had to go before the 1. This is why we label the point, so we could easily substitute inside of here now. So the reason why I'm writing it and I'm not doing it in my head is so that I could look up, right? You're trying to be efficient. You're not trying to give your brain too much of things to do. It's already maths. Maths is a confusing thing sometimes. Let us lay things out in a way where we could look and just pull values and put it, right? So we creating a system. We're trying to be ordered in our approach. It's important to have order when you're doing maths. So X2 is 8. X1 is 2. You see, I could look there easily and see what it is I'm putting inside it. That's why I'm labeling and I'm writing the formula, right? This is very important. It might take you an extra line. It's okay. The copybook and them cheap. If you don't believe so, check me. I have a set of copybook here. I will get you copybooks. 8 minus 2 going to give me 6. 13 minus 5 going to give me 8. I'm coming on this side here, right? But in your book, you should be writing coming down. I didn't give myself enough room. So the square root of 6 is 30, not the square. The square of 6 is 36. The square of 8 is 64. Right? 6 squared, 36. 8 squared, 64. Notice how I keep putting back the square root sign until I work out everything underneath here. 36 and 64 is 100. Square root of 100 is going to give me 10. Remember, the answer here going to be in units. 10 units. Everybody get that? Easy? Easy peasy? Right. So only know how to find the length of a line. Now, regardless of how they bring this in a question, they draw it, they give you a kind of fancy thing. the system for solving the length of a line or the distance between 2 points not going to change. It doesn't matter how they present the question. Identify the points, x1, y1, x2, y2, write the formula, substitute the values, work it out. Doesn't matter the values, right? Right, so the next one now, midpoint of a line. The midpoint of the line is not like the length of the line. The length of the line, we get in a single number in terms of units describing the distance between the point. The midpoint of a line is identifying a coordinate, a point. The name of it is a point. And we know that points have to have x and y coordinates. So the answer that we get in here, right? The answer that we get in here is going to be in the format of a coordinate. It's going to have an x and a y coordinate. It should talk about a point that is in the middle of the line. Everybody understand that? So your answer for midpoint is going to be literally a x and y coordinate, x and y values, right? So that means the formula is going to be slightly different to what we just did. But the first 3 steps is common in the sense that always begin by identifying the points. And again, for midpoint, because we're trying to find the middle of the line, we have to be using the endpoints. It cannot be a point anywhere else on the line, right? We have to be using the starting point and the end point to work out what is the point in the middle. Basically, we're trying to cut the line in half and say what that point is when the line is cut in half. So step 1, identify the endpoint. Step 2, label the points x1, y1, x2, y2, right? Same thing as the last one. Step 3, write the formula. Again, you're trying to be efficient. You're not giving your brain too much of things to do, right? You just wanted to work out the answer. So not do have to remember this and what x1 is and what you could look and see it right there, right? Write the formula, substitute your values and solve. x1 is -2. Now, ideally, I would tell students to always put your negative numbers in a bracket, right? So that you remember you need to work out signs. x2 is 4, y1 plus y2, right? 1 plus 5, and you're dividing those answers you get by 2. So -2 plus 4 will give me 2. 1 plus 5 will give me 6. When we divide 2 by 2, we get 1. 6 divided by 2 will give me 3. So the midpoint of the line is the point 1, 3. Easy? Everybody understand now? Yes? Right. Look the question. So, you're going to work this out for me just like how you did the last one. I'll leave any steps up. When you finish work it out, I'll solve it. And then we look at the other one. Good so far? All right, so you're going to correct this one. So again, remember what I tell you about the steps, right? The steps identify a point. So we have A is 10, 6. We have B is 20, 30. Right? This is x1, y1, x2, y2. Right? Identify the points, label the points. Next thing is you want to hit them the formula. Midpoint of A, B. Right? We have x1, a quote in the formula, right? Always quote your formula. Let's begin by quoting the formula and then dropping your values in it. x1 is 10, x2 is 20. So 10 plus 20 over 2. And y1 is 6, y2 is 30. 6 plus 30 over 2. I'm going to get here 30 over 2 and 36 over 2. All right, so that's going to give us 15 and 18 is the coordinates of my midpoint. Give me a thumbs up if you get that. Thumbs up. Nice. Everybody good. Right. So we're going on to something a little more challenging. Right. We're going to talk about something called the gradient of a line. Now, the gradient of a line has to do with how flat or how slanted or sloping a line is, right? So think about it like a flat road. You're walking on a flat road is an easy walk as opposed to walking up a steep hill. Anybody ever went hiking? Right? A hike would usually start off where you're walking and it's slow, then it gradually becomes a little steeper. And as you get closer to the top of the mountain, it starts to get very, very, very steep. Sometimes you have to go on all fours to climb, right? To walk up. Think about the gradient as a number that is going to give an indication of how flat or how steep something is. It could also give an indication as to whether it's sloping upwards, like when you're climbing up the mountain. And then when you don't reach the top of the mountain now and you have to come back down now, you're coming down at a different angle. Now you're coming down the mountain. So the slope is a descending slope. So the gradient could tell us whether the line flat, whether it's sloping upwards and how steep it is while it's sloping upwards, or if it's sloping downwards and how steep it is while it's sloping downwards. Some walks you might be able to just walk down the hill. Other walks you might have to put your hand on your legs and feel your way down because it might be too steep for you to just stand up and walk down. Anybody ever experienced that before? No? Malachi, right. Right? Remember when we went up Mount St. Benedict? Right? Good. Some of the things that we're doing here, like I keep telling you, are going to remain the same. Always identify the coordinates at the point. Label them. X1, Y1, X2, Y2. Quote the formula. Now, we use the letter M to signify the gradient. So you'll find very often in coordinate geometry, M is the variable that we use for gradients. Right? So you see the formula here says M is equal to y2 minus y1 over x2 minus x1. This is our formula here. And this is why it's important for us to identify the coordinates and then label them. So I'll talk about the formula first, and then we'll go and talk about the graph, right? So normal thing, put the formula, substitute the values. If you have negative values, always make sure, this is very important, to put them in brackets, right? Because you have a negative sign in the formula. Do not write it as 4 minus 2 because you see any minus sign there because you're going to get it wrong. You have to put back that minus sign as part of the formula. And if the number is negative, you put in that number in a bracket so that you remember that you have to resolve this sign. Minus by minus going to give me a plus. 4 plus 2 going to give me 6. Similarly, underneath here, 0 minus negative 3 going to give me a plus. And 0 plus 3 going to give me 3. So the gradient of this line is 2. A positive gradient indicates that the line is sloping upwards. Right? A positive gradient indicates that the line is sloping upwards. Everybody all right with that? A negative gradient is going to imply that the line is sloping downwards. So it means that a positive gradient, we starting from the bottom left and going up to the top right. It's increasing like this. A negative gradient would mean that we starting from the top left and going down to the bottom right. All right? Everybody okay with that? Right. Now, some teachers or some textbooks will also describe the gradient as the vertical rise, the amount we increasing vertically by, divided by the horizontal run, which is basically what this formula is. So if you look at the graph, we start at negative 2 here, and I am going up to 4. If you check the number of blocks, 1 block, 2 block, 3 block, 4 block, 5 block, 6 blocks. This is a vertical rise, a positive rise of 6. And then I am going across. I am starting from negative 3 here, and I'm going across to negative 2 to negative 1 to 0. That's a horizontal run to the right, which means it's going to be positive of 3. If I divide my vertical rise by my horizontal run, I will get the gradient, which is 2. Everybody understand that? And this is why when we change directions, let's say the point was going this way instead, then my horizontal run, because I'm going to the left, will be negative. Right? But I'm still increasing upwards. So the vertical rise going up this way will be positive. But then I'm going across to the left, so it'll be negative, and I'll get a negative gradient. So this is why a line that looks like this is going to have a negative gradient, and one that looks like this is going to have a positive gradient. Give me a thumbs up if you're okay with that. Right, so that's just some theory about the gradient of a line. So somebody could look at a line on a graph and automatically tell whether the gradient is positive or negative. Yeah? Right. A flat line, right? Or a line that is dead vertical like this, they have a gradient of 0. Right? As you get steeper, the gradient is going to increase in value. So as it gets steeper like this, it's going to be a larger gradient. So flat gradient is 0. It have no slope, no steepness. As we start to move up, slightly up, up more, up more, up more, the value of this gradient in terms of its numeric value is going to increase. Yeah? Right. So just like the others, got a little question for you to try it. Remember, we're using the steps. Identify points, label them, put a formula, drop them in the formula. All right, so work in this one for me now. Calculate the gradient between 1, 2, and 4, 6. Now, unlike the midpoint and the length of a line, we don't need the endpoints to find the gradient. It can be any 2 points on the line, but you need 2. Okay? All right, work this one for me now. So we're correcting. Remember what I said? We want to identify our points. So we have the points 1, 2, and 4, 6. Not all the time they're going to give us like labels to them, A and B, X and Y. We're still going to identify our points, label them in terms of X1, Y1, X2, Y2. Write our formula. M is equal to Y2 minus Y1 over X2 minus X1. And then we're going to work that out. M is equal to Y2 is 6, Y1 is 2, X2 is 4, Y1 is 1. So 6 minus 2 is going to give us 4. And 4 minus 1 is going to give us 3. Right? So our gradient is going to be 4 over 3, which is fine. Right? It's okay if we get a fraction as a gradient. You don't need to write it as a mixed number. We could leave it like this. All right, everybody okay with that? You all got this as a gradient? So it doesn't always have to be a whole number. It could be a fraction. More thumbs up if you're okay with that. Yeah? Okay. Siobhan, you good? Markai, Kisan. So I just want to introduce 2 concepts here, but I'm going to come back to it at the end after we do equation of a line. Gradients is an important concept here in this topic because we could use gradients to tell about properties of 2 lines. And when I say properties of 2 lines, you could talk about whether 2 lines are parallel. Parallel means that they're going in the same direction, they're the same distance apart, they will never intersect or never meet. Right? They're running parallel to each other. Or if the lines are perpendicular, perpendicular lines meet at a right angle at 90 degrees. They cross each other, similar to how the X and Y axis will cross each other and make a T. Right? This is what a perpendicular line would look like. It looks like a cross. Parallel lines moving in the same direction, equal distances apart at all times. Right? So it could go that way. It could go this way as well. That's what parallel lines look like. And this is what perpendicular lines look like. For parallel lines, they have the same gradient. Right? If 2 lines are parallel to each other, the gradients is going to be the same. Right? The steepness or the flatness is going to be the same. So the gradients are the same when lines are parallel. If 2 lines are perpendicular, the product of their gradients is -1. Now, in order to better understand or appreciate this products being the products of the two upper parallel lines here. See the mistake? I changed that one time. Two perpendicular lines. Right, the product of the gradients of two perpendicular lines is -1. In order for that to happen, two perpendicular lines, their gradients are the negative inverse of each other, negative reciprocal of each other. What I mean by that? So if the gradient of one line is 3, then the gradient of the other line is change the sign, flip the number. So for example, if the gradient of one line is 2/3, if the other line is perpendicular to it, then it will have a gradient of -3/2. Everybody understand this? Perpendicular lines, change the sign, flip the gradient. Another example, it could be if a line has a gradient of -1/5, then a line that is perpendicular to it will be +5 or 5/1. Give me a thumbs up if you understand that. Right? It's just a pattern. So it's a pattern. If the lines are perpendicular, then the gradients are the negative inverse of each other. So if one line is 3, if the gradient of one line is 3, then the gradient of the other line that is perpendicular to it will be -1/3, because 3 is over 1, right? 3/1 is the same as 3. So if we flip in the fraction and change in the sign, it will become -1/3. You okay with that, Melanie? Yes, everybody's okay with that, right? Similarly, if it's already a fraction, like let's say 2/3, and we are told that there's another line perpendicular to this line, what will be the gradient? Then the gradient of that line will be negative. I change the positive to negative, and then I flip in the fraction. 3/2. My thumbs up if you're right with that. Thumbs down if you're not okay. Everybody, right? No thumbs at all mean you understand it. Or no thumbs could mean that you're not following me at all. You're doing something else other than watching me. M1, or the gradient of this line here, is -1/5. So the gradient of a line perpendicular to it will be +5/1 or +5. Now, again, I'm introducing the concept here, but you'll understand it when we go on to this other part now, which is finding the equation of a line. Now, remember earlier on, I was telling you that when we have a line on the graph, we could come up with a general equation or general formula that describes the relationship between x and y coordinates. So this formula is going to help you to be able to identify points on the line, right? The formula is usually in the form y is equal to mx plus c. The x and y are coordinates. The m, as we learned just now, is the gradient. And c is something called a constant value, or the y-intercept. And I'll talk about the y-intercept and x-intercept afterwards, right? So the general equation of a line, when we are describing a line or defining a line, we are basically defining a relationship. So different lines, in terms of how they look on a graph, is going to have a different equation. Just like how different people have different names or different data booths. They have an identification card. Everybody going to have a different ID card. So people might have similar names, but they will have a different ID card, right? They would look different. So the ID card, we could think of as being synonymous with the equation of the line. So this equation of a line formula, right? A line might be y is equal to 2x plus 3. Another line might be y is equal to -1/3 x plus 4. All of these are different ID cards, if you want to call it that. They're different descriptions or identifications of a line. These two is going to tell me what the line would look like. I could actually use this in order to draw the line, right? So we could take it even further. We could say like, you know, each person going to have a different DNA, and the DNA is going to determine what that person looks like in terms of physical characteristics and other characteristics. That's what this equation of the line is doing. It's going to tell me what the line, I could use this to create the line on the graph. Everybody understand that concept? Yes, everybody? Right. So that's the formula then. So if everybody have a formula to make a Zara, to make a Malachi, to make a Melanie, right, which is their DNA, lines have a formula to make them too, right? The DNA of the line is the equation of the line. So we need to be able to figure out how we could write the equation of a line. This is what this part of the lesson is about. How to find the equation of a line. So there are two ways we could find the equation of a line. There's two methods. You know, maths like to confuse people, and they might give you 2, 3, 4 different methods to do the same thing. There's one method called the point gradient formula, which is in green here. This is my point gradient formula. And then this one that I wrote to the top here is called the slope-intercept formula. And that's why I tell you about this y-intercept here. It's about the gradient, which is the slope, and the c, which is the y-intercept. Right? We're going to talk about the point gradient formula. Before we get into that though, I need to say that to use either of these formulas, most of the time you're going to need two coordinates of any 2 points on a line, or if they give you the gradient and 1 point on a line. Why are you going to need that? Because each of the formulas, if you look at the formulas, you need to know what the gradient is, and you need a y1 value and a x1 value, right? Same thing inside of this other formula, which is the slope-intercept formula, right? The slope-intercept formula, I'm going to write the formulas next to them. So the point gradient formula is y minus y1 is equal to m into x minus x1. And the slope-intercept is y is equal to mx plus c. In both of them, you're going to need to know the gradient. Sometimes the question could tell you what the gradient is. Sometimes if they wanted to do more working, you have to find the gradient first. And after you find the gradient now, then you could come and put in our x1 and our y1 value, right? And work out the equation of a line. Everybody understand what I said? More thumbs up if you're okay with that. Yeah? Good. So we're going to talk about the point gradient formula first. So usually they would tell you which one to use. If they don't tell you which one to use, you could choose whichever one you feel comfortable with, right? All you need to pay attention to is what you have, what you're given. So you must always start these questions or answering these questions with what you're given, and then use what you have in order to find what you need to find. So point gradient formula. Let's just say given 2 points, you do have no gradient. They never tell you what the gradient is. So for example, 2 points on a line PQ are 2, 2, and 4, 6. Right? We want to write the equation of a line. I don't have a gradient. So the first thing I need to do is to find my gradient. We learn how to find gradients. We are experts at finding gradients now. We know that we need to write the formula. We know we need to identify the 2 points. We need to label them x1, y1, x2, y2. Right? Because we know the importance of working with our system. We then substitute our values into the formula. Right? So y2 is 6. Y1 is 2. We substitute that in here. X2 is 4. X1 is 2. We substitute that here. We work it out. 6 take away 2 will give us 4. 4 take away 2 will give us 2. We get a gradient of 2. So we halfway through our answer. We know what M is. Now I need to do the rest, right? Which is to substitute other values to find the equation of a line. So we take 1 point to get a x1 and y1 value. and the gradient that we just work out, and we substitute it into the formula. So I am going to use m is equal to 2 because I found that here. And I decided to take the point 2, 2. Right? Smaller numbers, easier to work with. I quote my formula as always quote my formula. Then I substitute values. Y1 is 2, M is 2, X1 is 2. Right? Everything else I put in back. My Y I put back, my negative sign I put back, X I put back, my negative sign I put back there. All I'm replacing is this, this, and this. After I substitute, I need to expand. 2 multiplied by x is going to give me 2x. 2 multiplied by negative 2 is going to give me negative 4. Right? After that, I need to make y the subject because the equation of a line should always be written in the form y is equal to mx plus c being a constant. So I move this negative 2 across my equal sign. Remember to change my sign, it becomes positive 2. The things that not moving is my y staying on this side, my equal sign staying there, my 2x staying there, my minus 4 staying there. I bring it across this positive 2. At that point, I could work out negative 4 plus 2. I'm going to get negative 2 here. So the equation of the line PQ is y is equal to 2x minus 2. This now, I could find any point on the line. If I take this equation and I substitute a value for x or a value for y, I will find what the corresponding value is, and I'll be able to determine a coordinate of a point on the line. That's the importance of the equation of a line. Right? Everybody okay with the point gradient formula? Everybody okay with the point gradient formula? Give me a thumbs up if you are. Yes? Okay, so I'm going on now to my point gradient formula. No, I'm still doing the point gradient formula. I'm just doing an example, sorry. I just doing an example where we have 1 point and a gradient. Right? So we don't need to work out the gradient for this one. I have the point and a gradient. So the example here, A, the point 32 is a point on a line with a gradient of negative 4. So no big set are working in this one. Short are working because we know what the gradient is. So it means that we're starting at a halfway point, right? The gradient, it depends on what you give on. It depends on what you give. You could use either the point gradient formula or you could use this one, the slope-intercept formula. But what will be consistent between both of them is whether you need to find the gradient first or if you could go straight to finding the equation of a line. Let me repeat that. Some questions, you may already have the gradient. Yes, the y equals mx plus c is the common method. That's called the slope-intercept form, right? And you have the point gradient form where you could also use this method to work it out. It's whichever one that you're comfortable with. The important takeaway I needed to get, the important one I needed to take away is that, 1 second, just give me one. Right. I was mentioning that the important takeaway is the question. Some questions, they will give you 1 point on the line and the gradient. If that is the case, like what you're seeing on the screen right now, is an easy workout because you have a x1, y1 value and you have your gradient. So it's easy to sub straight into your formula. Either you use this formula or use the other one that I have down here, y is equal to mx plus c. In some questions, they might give you 2 points instead and not tell you what the gradient is. In that case, if that's what you're doing, or if that's what you have to work with, you have to work out the gradient first before you can get to the point of writing the equation of a line. Because you need the gradient in order to work out the equation of a line. Understand? So this example that I'm going to look at now, we have a 1 point and we have the gradient. So that makes our life simple, easy. We could go straight to finding the equation of a line. We are using the method with the point gradient formula. We're using this formula here. Y minus y1 is equal to m into x minus x2. The other formula that you could use is the y is equal to mx plus c, right? Any one of these could work. Important thing is you need the gradient and you need 1 point to sub into either of the formulas. Here, I am substituting m to be -4. I am getting my x1 value from the point A, that is going to be 3. I'm getting my y1 value here from A, that is going to be 2. Right? Sub those into the formula. Everything else that you're not using, you're writing back. Y there, that there, x here. Right? We sub in here, here, and here. So we get y2 is equal to -4 into x minus 3. We multiply -4 by our brackets. We get -4x, and negative by negative is a positive. 4 by 3 is 12. At this point, remember, we need to make y the subject of the formula. Right? We need to make y the subject of the formula. So we move in -2 across on this side here to get +2. So we get y is equal to -4 plus x plus 2. Right? When you carry the 2 across, it's going to be plus 2. So we get 12 plus 2 to give us 14. So y is equal to -4x plus 14. The equation on the line is y is equal to -x plus 14. Everybody okay with that? Yes? Sure? All right. So we're looking at another one. But now we're going to use y is equal to mx plus c. Right? 1 second. Right. So slope-intercept form now, the more common method that you'll always find people using, y is equal to mx plus c. Again, it doesn't matter which method you use. Both of them pretty much going to operate the same way. The requirements for this method is that, again, you need to know the gradient, right? And you need 1 point to provide values for the x and the y. We will then use the gradient, the x value that you have and the y value you have to find what c is. And then you will rewrite this same formula, including our gradient and the answer you find for c. Sometimes in some situations, we are not given the gradient. We have no gradient in some questions. So we have to find the gradient, and in that case, we will need 2 points in order to find the gradient. Here's an example where we have 2 points on a line and we need to find the equation of the line. Before we could find the equation of the line, we need to work out the gradient using the 2 points. So just as we learned before, we label the points x1, y1, x2, y2. We quote our formula for gradient. M is equal to y2 minus y1 over x2 minus x1. We substitute our values. 4 minus, remember, if you have negative numbers, put them in our bracket, right? 0 minus minus 3. That's going to work out to give us 4 plus 2 over 0 plus 3. 6 over 3 is going to give us 2. So we have our gradient. Now we could actually go on to finding the equation of the line. So using the gradient, which is 2, which we just work out, and any of the coordinates, I'm going to use 0, 4. Right? We need that for our xy values. We will substitute them into the formula y is equal to mx plus c and solve for c. Right? So m is 2. The x and y would be 0, 4. Write my formula. Substitute my values. Things that are not using, I bring it down. This and this coming down as is. I sub in values here, here, and here. 4 is equal to 2 by 0 plus c. Right? Anything by 0 give us 0. Bring down the c. We found the value of c. This value of c is what we call the y-intercept. Right? And I'll explain what that is shortly. Y-intercept. Right? The y-intercept is the value of y when x is 0. You see x is 0 here, and this here, c. is 4, right? Anytime x is 0, we will get our corresponding y value. And I'll go back to something now we looked at earlier on to explain that better. But for now, let's finish our answer for the equation of our line. We're going to rewrite the formula y is equal to mx plus c, right? All we're going to substitute is the values of m, which we found earlier to be 2, and now we know that c is 4. So the general equation of the line y is equal to mx plus c. We are always trying to work out what m is and what c is, right? To find c, in this example, we use our value that we work out for m. We took a point on the line to get values for x and y so that we could work out what c is in order to write the equation of our line. Everybody all right with that? Give me a thumbs up if you're okay with that. Thumbs up. Everybody okay with that? Right. So one question before we close off. Here's my question. I'm giving you an easy question. Given a gradient of 3 and a point on the line as 5 and 15. I want you to write the equation for a line using 1, y minus y1 is equal to m into x minus x1, and 2, using y is equal to mx plus c. Right? So try that for me. All right, so let's correct this. So we have easy question here. Let's do the part 1 first. So always write what you have. So we have the gradient, which is m, that's 3. We have a point, 5, 15. That's going to give us our x1 and y1 values. Put a formula that should be next. Y minus y1 is equal to m into x minus x1. Then we substitute in. The things that you're not using is what you write back first. This is a little subsystem that I have within the system. So this is how I will approach it mentally, right? To have certain things I was doing in a particular order all the time. These things that are not using, I write back. So that I know I'm substituting here, here, and then here. Right? So it have no confusion there at all. Then I could work out next. Ask myself, okay, what's the next thing that I could do? Right? I don't need to do anything here on this side because I have this bracket to expand out. So let me deal with that first. I get 3x, 3 by negative 15 will give me negative 45. I can't work out anything here again. I can't work out here anything again. Okay, let me move things now. I'll move this over here. Again, watch my system. This not moving, this not moving, this not moving, this not moving, this not moving. All that moving is this. See it? Right. This staying here. This staying here. I can't do anything with this 3x. I could work out this. I'll get what? Negative 30. So y is equal to 3x minus 30. Everybody okay with that? Let's look at using y is equal to mx plus c. Again, I'm quoting what I have. So I have 5 and I have 15. This is my x, this is my y. That's what I need here. These three things is what I need. This, and this. Write my formula. Y is equal to mx plus c. What I put in? 15, 3, 5. This coming on here plus c. I'm working out this here first. 15, 15 plus c. Right? Something wrong? No, did I? 3, 5. M is 3. X is 5 plus c. 15 minus 15 is equal to c. Three minus 45 plus 15 negative 2t. Right, that's correct. I'm using the same values here. 5, 15, y is 15, x is 5, m is 3, 3 by 15 is 3 by 5 is 15. C is equal to 0. Well, it's not really an issue. We just write the equation as y is equal to 3x. If your constant is given as 0, it's not issue. The line could be 3x. So, 1 second. Right. So we have an error on this side here. That's why they're not looking the same. X1 is 5, and I have 15 here. Everybody see that? X1 is 5. So 3 by x is 3x. 3 by negative 5 is negative 15. So negative 15 plus 15 is what? 0. Everybody see that now? So both methods would give us the same equation of a line. Right? Gradients being the same, both equations is the same. Whichever method you use would yield the same answer. Right? They're just two different approaches. Everybody all right with that? So important to always check over your work. See? So even says make little mistakes sometimes. So that's why we check over all the time. Always check over your work. All right, guys. So that sums up our session for coordinate geometry. We covered all of the basics that you need to do coordinate geometry. The next session that we're going to do will be looking at working questions. So we pull some past paper questions. We understand our concept now. We want to take the system that we learn and apply it to our questions now, to test our system, to see if we understand what we learned and if our system working. All right. So that's it for today's session. Next week, we'll be looking at some questions. You can look out for some videos. I'm going to do some videos leading up to the next week's session where I'll work out a couple of questions and send for you. All right.